Today we'll be going through geometry set 3 and 4. Okay, let's have a look. Types of angles. We've got an acute angle. So an acute angle is an angle that is less than 90 degrees. And to see what a 90-degree angle is, we look at this one, a right angle. It's in an L shape, and we signify a right angle with a square. Okay, an obtuse angle is an angle that is more than 90 degrees and less than 180 degrees. And then we go to the next one, straight angle, which is a straight line, so it's exactly 180 degrees. A reflex angle is between 180 and 360 degrees. So with the reflex angle, we have a look at the angle on the outside. Okay, so it's not the angle here, it's the angle on the outside. Revolution is just a circle, 360 degrees, and then we have complementary angles, which are angles that add up to 90 degrees. So we have, for example, 60 and 30, those are complementary angles. 45 and 45, those are complementary angles. 20 and 80, 15 and 75, they're all complementary angles. Okay, and the opposite of complementary angles will be supplementary angles, which are angles that add up to 180. So, for example, we've got 130 and 50 degrees. We can also have 150 and 30 degrees. We can also have 90 and 90 degrees. It just has to add up to 180. Okay. And adjacent angles are two angles with a common vertex, which lie on opposite sides of the same arc. So, if you have a look at these two angles, they have the same vertex, but they lie on the opposite sides of the same arm. So for this arm it lies here, and for this arm it lies here. Okay, that's why they're adjacent angles. Alright, let's keep going. Let's have a look at these theorems. With revolutions, all angles must add up to 360. Okay, so we've got 125 here and 105, so if we add that up, we get 230, and then 360 minus 330 gives us 130, so the missing angle over here is 130 degrees. Okay, if we do this one here, we've got a straight angle, so we'll look at supplementary angles. The straight angle adds up to 180. 180 minus 42 gives us 138, so the missing angle is 138 degrees. Okay, as easy as that. And we have a look at these opposite angles, vertically opposite angles. They are always equal to one another. So, say for example, we have 30 here. This one would also be 30. So, over here, x would be 135. Okay, and if that's 30, this is 150, because remember, it's a supplementary angle, because it's a straight line. And if this is 150, what would this side be? 150 as well. And if you guys add up all these angles together, what number do you think you'll get? Okay, let's do it. 150 plus 150 gives us 300, 30 plus 30 gives us 60, 300 plus 60 gives us 360. What is 360? The total sum of a revolution, so that's why this is a circle. Okay, let's keep going. Parallel line theorems, so saying that these ones are similar, A and E are similar, B and F are similar, D and G are similar, and C and H are similar. So on a parallel line, all these angles which are on the same position are the same. Okay, and if we have a look at alternate angles, so you have a look at, just draw a Z to see where the alternate angles are. So D and F are equal, and we'll do a different color. C and E are equal. We just draw a Z this way or a Z the other way, okay, to find out the alternate angles. Alrighty, let's keep going. Co-interior angles are supplementary, so D and E add up to 180, C and F add up to 180. D and C add up to 180, and E and F add up to 180. Okay. Those are easy. Let's go to triangle theorems now. So with triangle theorems, we know that all interior angles of a triangle adds up to 180. So y plus x plus z should add up to 180. And the exterior angle, so if we extend this one, right? Whoops, I'll just redraw it. If we extend this line, that wasn't a good one either, but this angle would add up to the sum of these two angles, which is shown here. So D is the sum of A and B. Okay. Okay, you guys know what isosceles triangles are. They've got two equal sides. So AB and AC are equal, and therefore these angles are also equal. Okay, equilateral triangles are triangles with three similar sides, so the angles are always 60 degrees. Okay, here's an example here of what we did here. To find out x, we just add up 49 and 57, which gives us 106. Okay, quadrilaterals are sides with shapes with four sides. So we've got a parallelogram, a rhombus, a rectangle, and a square. Okay, with a parallelogram, there are parallel sides, so these two are parallel and these two are parallel. Okay, and the diagonals of the parallelogram bisect each other. Okay, which means to cut exactly in half. Okay, and with a rhombus, it's the same as a parallelogram, and the diagonals also bisect each other, but at 90 degrees. Okay, so these are all 90 degrees. Okay, have a look at a rectangle. Rectangles pretty straightforward. Diagonals are equal, interior angles are always 90 degrees. Same with square, all sides are equal, interior angles are equal to 90 degrees. Okay, we'll have a look at polygons. To find the internal sum of angles, the sum of internal angles, what we do is we look at this formula here. 80 times by n minus 2. N being the number of sides. Okay, this can apply to any polygon. Okay, so if we have a pentagon, that's five sides, so we substitute n to be 5, 180 times 5 minus 2, which is 3, and we just find out what 180 times 3 is to get the sum of interior angles. Okay, and the sum of exterior angles of any polygon always adds up to 360. Okay, so just remember that, and all you need to remember is these two formulas. Okay, so 180 times n minus 2, and this one here, the sum of exterior angles of any polygon always adds up to 360. Okay, these are pretty straightforward. We'll skip that. We just went through these and have a look at geometry. I'll just quickly do the right hand side. Okay, so we know that this whole thing is 60 degrees and this one's 35. So what would A be? A would be 25 degrees because the 60 degrees minus 35 gives us 25, so A is 25. Okay, so let's have a look at the other one. We've got a revolution here because if you add up all the angles, it will make a circle. And we know that the revolution adds up to 360. We just need to add up the given angles and see what the missing angle is. Okay, so 263 plus 45, that gives us 308. Okay, if these two are 308, B is equal to 360 minus 308. What is that? It's just 52 degrees. Okay, that's it. do this one. We know that this is 78, so 78 will be 78 here as well, because alternate angle theorem. And if this is 78 and we know that this is the supplementary angle, what is the missing angle here? We just do 180 minus 78, which gives us 102 degrees. Alrighty. We know that this is an isosceles triangle, so we know that this x will be 70 as well. Alrighty. This one's a supplementary angle, so we know that x is 70 degrees because a supplementary angles add up to 180, so 110 plus 70 gives us 180, and this is a quadrilateral, right? So with any quadrilateral, it adds up to 360 degrees. So we know that this is 70, these two are 90 degrees, denoted by the square. So 90 plus 90 gives us 180, 180 plus 70 gives us 250, so y is equal to 110 degrees. Okay, because we're just looking for 360, right? So we need 360, so the remaining angles are 70 and 110. Okay. Find the angle sum of a decagon, so we just do 180 times 10 minus 2, which is 180 times 8. That should give us 1,440. Okay. Each size of each angle, so we do 189 minus 2, which is 180 times 7. 180 times 7 gives us 1260, but we need to find the size of each angle, so we do divided by 9, which should give us 140. Okay, as easy as that. Alrighty, we'll just skip these and let's move on to measurement. Measurement's pretty easy, just follow this table and you should be okay.